Okay, this video is on an introduction to chemical bonding and the difference between ionic and covalent bonds. So this is the note paper that we'll be working on, and you can just follow right along. All right, so the goal of atoms forming chemical bonds is for every atom to acquire an octet, which we've talked about before, which of course means 8, to acquire an octet of valence electrons, or 8 valence electrons, okay? And that was if you can remember, that was the main idea in terms of ion formation, right? Whether atoms gained electrons to get 8 or whether they lost electrons to get 8. And so this idea of acquiring an octet of electrons can be accomplished 2 ways. And this is a pretty big deal. The first way is by transferring electrons, which means somebody gives an electron and somebody takes an electron, or by sharing electrons. And so that's the second way. So the first way is transferring or giving and taking, and the second way is sharing electrons. And that's the difference in the 2 types of bonding that we discuss, which are ionic bonding and covalent bonding. So the next heading on your paper says, well, how do I tell if it's ionic or if it's covalent? So my first kind of key word here is an ionic bond. So an ionic bond, let me see how I want to describe this. It is a metal and a nonmetal. And it involves the transfer of electrons. Okay, remember transfer means giving or taking of electrons. Of course, your metals are on the left of your metalloid line and your nonmetals are on the right, so we have to keep that in mind. So anytime we have an ionic bond, we have a metal and a nonmetal, and that involves the transfer of electrons or the gain or the loss of electrons. If you want to write that, you can. You can write gain or loss of electrons. And as you might imagine, an ionic bond is made of ions. Okay, that is the root word, after all, in the word ionic. And so an ionic bond involves a metal and a nonmetal. It involves the transfer of electrons, the gain or the loss of electrons, and an ionic bond is made of ions. Okay, that's very different from a covalent bond. And a covalent bond is formed between 2 non-metals and it involves the sharing of electrons. Okay, so all of a sudden in this second example, we're talking about electrons being shared, and we are no longer discussing the gain or the loss of electrons. So that's completely and totally different. That's ionic. And in covalent bonding, we're talking about 2 nonmetals, and it's the sharing of electrons. And that might seem like kind of an interesting idea, and we'll get into specifics of that later on. But so ionic and covalent are totally different. They involve 2 different types of atoms. And so we will quickly learn how to kind of differentiate between the 2 and how to discuss whether or not a bond could be ionic or covalent. So that's kind of the next part of your note paper, is a discussion of some ionic bonding examples. And then in a minute, some covalent bonding examples. So remember, ionic has to have a metal and a nonmetal. Okay, so and we have talked about this in class before, I believe. But probably the most famous example of ionic bonding is the bonding between sodium and chlorine. Okay, and I think most of us know that this forms salt, very common substance. And so we're going to talk about it from a little bit of a different perspective. So I'm going to draw over here because it may have been a little while. since we've talked about valence electrons, remember they're the outermost electrons. They're important in everything here on out. And remember the way to count them is that it goes 1, 2, 3, 4, 5, 6, 7, and 8. Whoop. With the one exception of helium, who only has 2. And so that's the way we count valence electrons. And so valence becomes very important in this discussion. So what does ionic bonding look like? Well, it looks like this. So here comes sodium, okay? And it might be helpful if you have your periodic table out. But sodium is in group 1, and sodium has 1 valence electron. So I'm going to give sodium 1 dot. Okay, these are actually called, I believe they're called Lewis dot structures. And basically the dot is just showing you how many valence electrons. So sodium comes in with 1 valence electron. Chlorine, okay, chlorine's all the way over at the right. Chlorine comes in with 7 valence electrons. And I'm going to give chlorine 7. Okay, just like this. Remember the goal of all these things is to have 8 valence electrons. And so what happens here, of course, is sodium says, hey, chlorine, would you like my valence electron so that you can have the magic number of 8? And sodium says, and chlorine says, yes, I would, right? So what happens is chlorine takes an electron. Chlorine acquires a charge of -1. It's an anion. Sodium, who has lost an electron, acquires a +1 charge. Is a cation, right? And all of a sudden, both have 8 valence electrons, and everything is right in the world, so to speak. Okay, both sodium and chlorine now have 8 valence electrons. It was accomplished by a transfer. Sodium lost his electron. Chlorine gained an electron. And if you look at my charges, I have a +1 and a -1, and they cancel out perfectly, which gives me a ionic formula of it takes 1 sodium and 1 chlorine, and thus the chemical formula for salt is NaCl. So, let's do another example. So let's do a second example of what about the bonding between magnesium and, let's do fluorine. Okay, so my first thought here is, could this possibly be ionic? Remember, to be ionic, we have to have a metal and a non-metal. So, could it possibly be ionic? Absolutely. Magnesium is a metal, fluorine is a non-metal. So, we're going to see if this works. So, we'll draw our dot pictures just like we did a minute ago. Magnesium comes in with 2 valence electrons, right? It's in group 2. And fluorine comes in with 7. Remember, the goal is for everybody to have 8. Fluorine is so close, it just needs 1 more. So magnesium says, hey, fluorine, do you want my 1 electron? Because he doesn't want both. And fluorine says, of course I do. Okay, and fluorine's good. But magnesium is not. Magnesium still has 1 electron left to give away. And so what happens is we bring in a second fluorine. So if I were to bring in a second fluorine, who comes in with 7 valence electrons, magnesium now says, hey, fluorine number 2, would you like my second electron? And fluorine number 2 says, of course I would, right? And so then now let's talk about our charges. Magnesium has lost 2 electrons. That gives me Mg plus 2. This fluorine has gained an electron. That gives me F minus 1. My second fluorine has gained an electron. And that also gives me F minus 1. Okay, now if I look at my total charges, I have +2, -1, and -1, and that adds to 0. And that's what we want. Everybody has an octet, and if I go to write a formula, which is what we'll be doing very soon, I have 1 Mg, and I have 2 fluorines, and that becomes the subscript at the bottom, and that is read as MgF2. And notice I didn't write any charges in my formula because the charges have canceled out. +2, -1, and -1. So these are 2 examples of ionic bonding. Okay, there are many, many examples of ionic bonding. And we can draw these pictures for a lot of things. But this is the very intro to looking at examples of ionic. Remember, ionic involves a metal and a non-metal. And involves the transfer or the gain and loss of electrons. Okay, it involves ions, right? See, there they are, all the ions. And everybody has an octet. Okay, so this is a very simple kind of introductory example to ionic bonding. And so now we want to look at, well, then what's a covalent bond? And this one's a little bit harder to understand, and it's actually the one that we'll be dealing with much later, or not much later, we'll be dealing with in more detail in terms of what it really means to share electrons. So, remember, it's two nonmetals, and they share. Okay, so just writing that as an example. Okay, let me think of something that would make sense here. Okay, let's talk about this. This is a real thing that exists, and it is the compound F2. Okay, which really means that there are two fluorines that have somehow bonded together. Now, if you were to think about this from an ionic perspective, well, hold on, I got ahead of myself. Okay, let's draw this. So I have two fluorines. So I have one fluorine who comes in with 7 valence electrons, right? Because fluorine has 7. And I have a second fluorine who comes in with 7 valence electrons. Now, if you were to think about this in the same way we thought about ionic, you might think, well, maybe this fluorine gives his electron to this fluorine. And that would satisfy, I mean, I'll do it. Don't do it on your paper, but I'll do it. So if this fluorine gave an electron over here, this one's good, but now this guy only has 6 and we're never going to get there. Okay, so that must not be how ionic bonds work. And remember, the definition of an ionic bond, that must not be how covalent bonds work. So if you remember, the definition of an ionic bond was the transfer of electrons. So that's what I just tried to do, and it didn't work. So there's got to be something different. And so in this different type of bonding, which is covalent, instead, they share electrons. Okay? And so this gets a little funny, and again, we're going to spend much more time doing this, but what happens is the two fluorines kind of get close together, and they say, okay, look, what if we do this? What if I take this electron and this electron? And what if I'm going to connect them together, okay, which is like a bond. And what if we say that those two fluorines are going to share those electrons? Now there's 2 of them, right? 1, 2. And each of those fluorines would both have access to those 2 electrons. Well, look what that does for us. So if I look at the fluorine on the left, who has 1, 2, 3, 4, 5, 6 valence electrons, but then it has access to this and this electron, which gives a total of 8. Okay, it's an octet. And if you look at the fluorine on the right, it's the same thing. This fluorine has 1, 2, 3, 4, 5, 6 electrons solely to itself, and 2 electrons in the bond. So both fluorines here have an octet of electrons, and this is the picture for the bonding that exists. This is called a Lewis structure. And there's a whole lesson on how we draw these Lewis structures. This is called a covalent bond. Okay, why? Because they are sharing those 2 electrons. And that bond is made up of 2 electrons. Okay, so that's one example of covalent bonding. I don't know how many other ones I want to do because I don't want to get ahead of where we are right now. But that is an example of covalent and ionic bonding.